Welcome to 5.4. Our objective here is to use properties of the natural exponential function and apply them for differentiation and integration. So let's start with what is the natural exponential function? If you see on your notes, it says, if f of x equals the natural log of x, then the inverse of f of x equals e to the x. Why is that? Let's take a look. Let's start with the function f of x, or y, equals the natural log of x. If we take the inverse, we're switching the x and the y. X and y get switched. If we want to solve for y, how do we do that? We have to get the y unstuck, so we do what's called exponentiate. Exponentiate with base e. That means write this equation such that the left side is the exponent with base e and the right side is the exponent with base e. This is called exponentiating. Exponentiate both sides. That's what we're doing in this step. There's other ways to do it, but that's a proper technique. After that, we have e to the x equals, using our inverse property, e to the natural log of y is just y. So there we have y equals e to the x, or written with proper inverse notation, inverse of f of x equals e to the x. So let's talk about some of the properties of e to the x, and then we'll get into its derivative. Let's start by how do we graph it? Remember some things about the natural log function. First of all, the natural log function has a vertical asymptote at x equals 0. What does that mean about its inverse function? It has a horizontal asymptote at y equals 0. So we can graph that horizontal asymptote along y equals 0. Secondly, we always know two main points on the natural log graph, 1, 0, and e1. What does that mean about our inverse function? That's right. We reverse those points, switch the x and the y. So 0, 1 and 1e. Let's find those points. 0, 1 and 1e. How much is e? About 2.7. Now we can connect those with a nice smooth curve, and there it is, our exponential function. Some things that we want to say about our exponential function. It is continuous and increasing everywhere. We'd also like to say about how it has, maybe we review some limits here. The limit as x approaches infinity of f of x as x approaches infinity equals infinity. However, going the other way, as x approaches negative infinity, where does the function head? It gets closer to 0. There is no restriction on the domain, left and right forever, but here there's a restriction on the range. So some things you know about the natural log of x, reverse them, you know them about the exponential function. Some really important properties to know about the exponential function, such as the inverse properties. The natural log of e to the x is just x. E to the natural log of x is just x. These are the inverse properties, know them. Okay, inverse properties, know them. Then we have our other properties of the exponential function. When we're multiplying the numbers, we add the exponents. When we're dividing the numbers, we subtract the exponents. And when we have an exponent of an exponential expression, the exponents get multiplied. So know these three properties. Let's talk now about the derivative of the exponential function. So if we talk about the derivative, we ask ourselves first, what does derivative mean? Derivative means slope. So as we take a look at this graph, we can ask ourselves, what is the slope along each point? So taking a look here, the slope looks very shallow. Maybe we'd estimate close to 0. Then as we move to the right, the slope gets a little bit steeper, more positive. At 0, 1, it looks like the slope is probably 1. As we move to the right, the curve gets steeper, so the slopes get steeper. Well, think about those values. Close to 0, slope is increasing, slope is increasing. So as the graph increases, the slope is actually increasing too. Well, that means that the slope values will fall exactly on top of the function values. What does that mean for our derivative? The derivative with respect to x of e to the x is itself e to the x. This is the easiest. The easiest. And I'm not trying to be silly. I'm just trying to point out that e is e. E is e. E is the easiest. I guess I'm trying to be a little bit silly, but that's to help you remember. Now, normally, it's not just going to be the function e to the x that we're deriving. So really, we want to remember it in terms of the chain rule. The derivative with respect to x of e to the whatever else, call it u, is e to the u du dx. The same exact function times the derivative of the inside stuff. In this case, that's the exponent. Memorize this, but hopefully it's not too hard to memorize because it's the easiest. The derivative is itself. Can we practice a few? Let's go. Find dy dx, this guy right here. Well, e to the stuff. We remember it's the easiest, so dy dx is e to the 5x minus 1. The exact same thing that we see here, repeated. But because the exponent is more than just x, we do the chain rule. The derivative of the stuff, the exponent, is 5, so times 5. We probably wouldn't see it like this. We'd probably have it written as 5e to the 5x minus 1. Put the 5 in front, then we don't have to worry about any multiplication symbols. Yay! Isn't that awesome? You want to try one on your own? Pause the video, come back. So let's see what we've got here. Again, this is like e to the u. Don't fret about the constant multiple. We know it hangs out in front. So dy dx to the constant multiple, easiest function, which means I don't do anything, I just write it down, times the derivative of the stuff where x was supposed to be. That derivative is cosine of x. Done. Maybe we clean it up a bit and we write it as 2 cosine x times, now perhaps I want parentheses there. I don't want to confuse that the e function is inside the cosine function. So those parentheses are kind of necessary. Let's take a look at this one. Now sure, we can do what we've done before, e to the u du dx. However, if you can simplify first, please do it. It's going to make it so much easier. E to the natural log of x. This section right here is using the inverse property. E to the natural log, bye-bye, of x left over. So I'm not doing a derivative yet. I'm rewriting this function. So rewriting, I get 3 times x. This becomes just x. Now when I do my derivative, I already know this rule. It's not an exponential function. My power rule gives me 3. Done. Now, because these are so easy, I'm going to take this time to venture into some more complicated problems. Not really complicated, just slightly a step up. I see an exponential function. It is all alone in the numerator, and then there is a denominator. This is a quotient. What does that mean? Quotient rule. Quotient rule. From an AP exam, but the quotient rule combined with the exponential function. So what is f prime? Well, remember our quotient rule. Gf prime, 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 minus fg prime over g squared, where f is the top and g is the bottom. So what is f prime of x? Now probably, you know, if we're using f here, we don't really want to use it here, but if you've memorized it in terms of f and g, it's easier to remember that way. So just for the sake of not being confusing, I'm not going to call those f and g. Sometimes you'll see this rule written as u and v, so we'll practice it that way. vu prime minus uv prime over v squared. How about this? Just remember that you always start with the denominator. Whatever the denominator is, it goes first, non-derivative, okay? So f prime of x, denominator 2x, derivative of the numerator. Well, e is the easiest, so I repeat what I see, e to the 2x, the easiest. But I see more than x where just x is supposed to be, so I say the chain rule, times 2. Minus top, e to the 2x, derivative of the bottom, 2. All divided by the denominator squared. Notice how I put it in parentheses so I don't get confused of what I'm squaring. There's my derivative, but we can clean it up, so let's do that. 2 times 2 to make 4x e to the 2x minus 2 e to the 2x over, square both, 4x squared. Still not as clean as it could be because I can take out some common factors. Take out a common factor of 2, take out a common factor of e to the 2x. Left behind is a little bit more in the first one, 2x minus 1 over 4x squared. How is that helpful? Well, factored form is usually prettier, and I can divide out a 2 from the denominator also. So I do that, and I get finally e to the 2x times 2x minus 1 over 2x squared. Yay. Now earlier I showed you one where when we mix the natural log and e, we use some inverse properties, but don't think that's the way it has to happen all the time. Here I want f prime of 0, so what do I do first? Find f prime of x. If I have the natural log function, I think of my natural log derivative. The derivative with respect to x of natural log of u is u prime over u. The derivative of the u, the inside stuff, is 1. Derivative of x is 1. Derivative of 4 is 0. Derivative here, I use my e. E is the easiest. Repeat what I see and multiply by the derivative of where x is supposed to be. All divided by u. X plus 4 plus e to the negative 3x. This is good. We can simplify it, but remember our goal is to find f prime of 0. So now I'm going to plug in 0 where x is. F prime of 0. Top is 1 plus 0 plus e to the negative 3 times 0. In the denominator, 0 plus 4 plus e to the negative 3 times 0. Now with your exponential functions, take your time when you're evaluating. In the numerator, 1 plus 0 is gone. E to the 0 is 1, so plus 1 times 3. 0 plus 4 is 4. E to the 0 is 1. What's left over? 1 plus 3 is 4. 4 plus 1 is 5. Oops, just realized I had a negative here and I didn't follow through. Negative here, so my numerator, not 4. Let's fix that. Let's take our time. 1 plus negative 3, negative 2. There we go. That looks a little bit better. Let's do one more together. Again from an AP exam, this time testing limits. But what about limits exactly? F of x equals e to the x. Which of the following is equal to f prime of e? If I see limits, I want to think of my limit definition of the derivative. The limit as h goes to 0 of f of x plus h minus f of x, all divided by h. Well, if f of x is e to the x, this is how it changes. X plus h goes where x is, so e to the x plus h, minus f of x is e to the x over h. But it's asking for f prime of e, which means x equals e. So wherever I see x, I put e in its place. Okay, which one looks like that? E to the e plus h minus e to the e over h. Looks like it's C.